Hello everyone, we are meeting again for another case study. This time we are going to look at the design and manufacturing and design for manufacturing and assembly application on the design of a AH-64D helicopter. Okay, this is a case study which has been carried out at McDonnell's, McDonnell Douglas Helicopter Systems, Arizona, actually. Uh, on the introduction, where we already know that the DFMA, focuses more on the reduction in part count, reduction in the assembly time, and the simplification of sub-assemblies, and it encourages the concurrent engineering of the simultaneous engineering. Okay, so many people have definitely been, have utilized DFMA and they have benefited by the concepts. Okay, so here we are going to look at how this is being used for the helicopter made by McDonald's. Okay, high speed machining also is one of a new concept where the speed of the spindle speed is more than 10,000 RPM. Okay, it uses when it is used in a DFMA environment, it allows part count reduction by providing the machining capability to rapidly create geometrical parts normally designed with many mechanical, fastened sheet metal parts. Okay, instead of using multiple sheet metal parts, this one process where the HSM uses and then try to machine these things. Very thin walls it can machine. It combines rough and finish machining of material into a single machine operation. It reduces the heat buildup and the thermal growth and allowing the stable machining operations and very close tolerance features it can be able to carry out. Again, in its application, here they have used complex assemblies are converted into simple part assemblies, reducing the part count and simplifying the assembly process. Generally, the tooling manufacturing process can be eliminated because of such kind of things. They also use composite design of very complex and composite design, which are parts which are combined with each other. Composite design helps in the assembly process since it can help in minimizing the number of parts by combining the several parts into one. Okay, it reduces a lot of expensive tooling. Okay, that is what they're trying to tell. Tool wear and tear is another problem which is encountered in the composite manufacturing process, and all these things are eliminated by the DFMA and the HSM. The superplastic forming is a process in which a specific type of aluminum alloy or aluminum 2004, for example, is formed by blowing very hot air against a sheet of a metal and over the tooling inside an oven in order to shape the metal into the parts configuration. So whatever is the mold shape, this is more like a blow mold that happens. Okay, since there is virtually no tear, there's very low rejection. That is what they say, and superplastic forming is limited to very small parts due to its oversized limitations are there. Okay. So here again in the McDonnell Douglas Corporation, the military division's saving has been quite substantial, and they have saved quite a lot of money in after they implemented the DFMA tools. So coming back to the statement of the problem, during the engineering development of Longbow Apache helicopter, LA helicopter, the company or the McDonnell's Douglas Helicopter Systems MDHS found that the traditional design methods would not provide adequate support to the challenging budget and schedule. New design methods had to be obtained and implemented in order to support the program objectives. Now, they have implemented DFMA just to bring down the cost of this because they did not have the budget to spend that much for over 500 according to Jeffrey Boothroyd. We know that Boothroyd and Dewhurst are the father of the DFMA thing and concepts, and he's a professor of industrial and manufacturing in the University of Rhode Island, and he brought the concepts of design for assembly and design for manufacture, and in the late of 1970s at University of Massachusetts. Of all the issues to consider, industry was most interested in design for assembly. Okay, so statement of the hypothesis is that what do we assume based on the success of DFMA to reduce cost and time on the other programs? It follows that the application onto the Longbow Apache modernization program should have similar savings. So that was a requirement. That was the understanding that they had brought. The simplification of the assemblies and the reduction of fasteners will also reduce weight to the crew station area. Okay, so how did they do that? They try to work they try to work on the design. Okay, there was an integrated product development team, and they used concurrent engineering where the representatives of several organizations such as engineering, manufacturing, procurement, supplies, product support, quality, and others, they all work together to the development of product design. This design is then brought into production in a very short period of time without the budget and lengthy schedule usually encountered by the other organization without a team concept in place. Okay, so they have overcome all the such kind of hurdles and they have come. 6 helicopters were completed in the prototype phase, and the experience obtained from this phase was applied to the Longbow initiative projects. Okay, they tried to use one to the other. During this project, design and producibility engineering and and planning was developed and implemented with the purpose of improving and the previous prototype aircraft configuration and they used DFMA to aid this. It was applied for limited number of parts within the crew station and improved the extended avionics bay and of the Longbow Apache helicopter. Data was gathered and recorded by the IPD team, Integrated Product Development Team, and compared to the baseline prototype helicopters which were designed without using DFMA. They wanted to find out whether DFMA is useful or not. Okay, so the collected data was loaded into the software, and whatever the software recommendations was implemented. Right, so these are the results. Okay, the pilot instrumented panel. So the part count was brought down from 74 pieces to 9 pieces. The fabrication time was brought down from 305 hours to 220 hours. The assembly installation time came down from 150 hours to around much less than 8 hours. And the total time of the entire thing was around 697 hours, is came down to 181 hours. The weight was reduced by from 3 kilograms to 2.74 kilograms. Okay, and a cost reduction of 74%. Okay, so this clearly justifies the usage of DFMA in all the new development process. So this is the panel that was developed, and panel and the cluster, all these things were developed, and for such kind of applications, definitely the DFMA reduces the assembly complexity, the number of parts, etc., all such kind of things. Okay, so we already talked about the cost reduction, etc. Concluding, the utilization of DFMA has not been extensive. Indications are that the DFMA can successfully contribute when cost, weight, and schedule are the prime drivers for the development of the program. So what is that is required for this? Training is must. Okay, people must have the concept of DFMA. The management's commitment to DFMA can bring down the success, can bring in the success of the program, and making the decision on educating the employees. Okay, so it's a clear recommendation is that this it was found that the design for manufacturing and assembly utilization by the aircraft industry can present great advantages. Every gram of the flying helicopter, when it comes down, a lot of saving that happens there. Okay, so that is the end of this case study. We found that the how this has been helpful in making of this helicopter design and manufacture, and how the DFMA was utilized in McDonald's company, right? Okay, until we meet again, thank you for, all very much for the listening. Thank you very much.